What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at a possible rational function when we're given a picture of this thing. So we'll be given a picture of a graph, and we got to figure out a possible rational function for it. So let's go. Now here's an example we're going to play with here and go through. So check this out. Now I want to go through just the general formula. So in general, when you are writing a rational function given a picture, you're going to take a look at a couple of things. Now we're going to go ahead and draw that because a rational function, remember, is of the form p of q over or p of x over r of x or whatever letters you want. So in general, you're going to have this polynomial over another polynomial. So that's going to be the general form of the rational function, and they're going to be just a whole bunch of factors. So let's take a look at how these things play out. Now, one of the first things you want to analyze is what's called the horizontal asymptote. And the horizontal asymptote, that is going to go either in the numerator and the denominator. So the horizontal asymptote, that fraction would be that. So let's kind of start to put this together for our possibility here. Now, the horizontal asymptote, if we look here, so I'm going to highlight this, the horizontal asymptote is right here, this line, which we can tell is y equals 2. So that value, y equals 2, or negative 2, y equals negative 2, that's my horizontal asymptote, so that will go in the numerator. Now the next thing that we want to look at, so let me go ahead and erase these pieces right here. You want to look at wherever the x-intercepts are. So we're going to take a look at the numerator first. So the x-intercepts, any factors that we get for x will go on the top to x-intercepts. So let's take a look at where they are. Well, we've got one right here at x equals negative 1. So if we have an x-intercept of negative 1, so my x-intercept, I've got 1 at x equals negative 1, which means that factor would be x plus 1. So I'm going to write x plus 1 in the numerator. Now my other factor, is going to be, or my other zero root x-intercept solution is x equals 2, which means my factor is going to be x minus 2. So my x-intercepts go in the numerator. Oops, I started right. X-intercept again. Ha! That factor is going to be x minus 2. Now, this particular factor, check this out, right? So this guy bounces right here. So anytime you have a factor that bounces or a zero that bounces, that means that factor could repeat an even degree time. So we're going to put a little squared next to x minus 2. So those take care of the numerators. Now, one other thing that could go potentially in the numerator and the denominator, and I'll talk about that in a little bit, could be a removable discontinuity. And I'm just going to abbreviate that RD, or a hole in the graph. Now, we don't have any holes in this graph, but if we did, whatever that factor is, that would be in both the numerator as well as the denominator. So any holes or removable discontinuities, those factors go in the numerators. That's right. So that takes care of the numerator in this piece. So let's get after the denominator. Now the denominator, we're going to analyze our function right here in this value. So we're going to look for our vertical asymptotes. So anywhere we've got vertical asymptotes, that is going to go in the denominator. So any vertical asymptotes will go in the denominator. And the vertical asymptotes we're going to also have to analyze the end behavior of the vertical asymptotes. So let's see what we got here. So we're going to take a look at the vertical asymptote on the left, and that is going to be over here at x equals negative 2. Now, if x equals negative 2 is my vertical asymptote, that means the factor will be x plus 2. Because remember, we switched the sign for that. Now, here's where I want to analyze the end behaviors of that guy. So see how both of these around near that asymptote, they both go down, down, down. So that means kind of like how the x-intercept that bounces. If you have a vertical asymptote and both ends go in the same direction as they approach that vertical asymptote from the left and right side, that means we're going to take that vertical asymptote, we're going to square that, bro. That's right. So squared for you, Mr. X plus 2. Now, when I look at my other vertical asymptote, that is over here at x equals 1, 2, 3, which means the factor is going to be x plus 3. Oops, sorry. Oops, my bad. See, that's a common mistake right there. Be careful with that. That's going to be x minus 3. So that will be the vertical asymptote for x equals 3 goes in the denominator. Now, my end behavior for this guy, if I take a look here, they go in opposite directions. So that means that's going to be an odd degree. So we'll just leave it at 1. We don't need to make that cubed or anything like that. That could be a possibility, but we're going to keep it simple. We're going to use the lowest possible values. So that's it. So we've put together this possible rational function given this graph. So thank you guys for watching. I appreciate you, and I hope you have a magical, wonderful day, because there's simply no good reason not to. I'll catch up with you later. Have a good one. Peace out.